Hi students, now we are going to recall some important formulas on the basis of refraction at spherical surface. Now, point number 1. When refraction occurs from rarer to denser medium. What is the diagram? When refraction occurs rarer to denser medium. This one diagram. Okay? In this case, what is the formula? Mu1 whole by minus u plus mu2 by v is equal to mu2 minus mu1 whole by r. This is one formula. Now come to second formula. When refraction occurs from denser to rarer medium. In this case, we interchange mu1 and mu2. In this case, what is the formula? Mu2 by minus u. Please observe carefully this formula. In the place of mu1, we are going to substitute mu2. In the place of mu2, we are going to substitute mu1. That means plus, what is mu2 here? Mu1 by v is equal to, what is mu2 here? Mu1 minus, what is mu1 here? Becomes as mu2 whole by r. Okay? Now, go for third formula. Point number 3. Power of power of refracting surface power of refracting surface P is equal mu2 minus mu1 whole by R. Once again, power of refracting surface is given by P is equal to mu2 minus mu1 by R. Now, point number 4. First, principle of the first principle of focal length. Focal length formula is given by F1 is equal to mu1 into R whole by mu2 minus mu1. Once again, the first principle of focal length is F1 is equal mu1 R whole by mu2 minus mu1 formula. Now, point number 5. The second principle focal length F2 is equal mu2 R whole by, what is the formula? Mu2 minus mu1. Once again, the point number 5. This is point number 5. Second principal focal length is given by F2 is equal to mu2 into R by mu2 minus mu1. If it is first principle, mu1 will becomes on the numerator. Second principle, mu2 will becomes. It is easy to clue to remember. Okay. Now we are going to discuss some numericals on this basis. Please observe carefully. Numerical. Okay. Slowly I will write. After that I can elaborate and explain. Light from a point source in air falls on a spherical spherical glass surface. If mu means what is mu? Refractive index. If mu is equal 1.5 comma and radius of curvature radius of curvature is 20 centimeters. The distance of light source from the glass surface is 100 centimeters. At what point, at what position will the image be formed? This is the question. Once again, I am reading slowly. Please listen carefully. Light from a point source in air falls on a spherical glass surface. If refractive index mu is equal to 1.5 and radius of curvature is 20 centimeters, the distance of light source from the glass surface is 100 centimeters. That means u. At what position will the image be formed? This is the question. At first, we have to write the given data. So, what the examiner given to us? Given refractive index mu2 is equal to 1.5. Then what is mu1? 1. Because light is traveling from rarer medium to denser medium. If light is traveling from rarer medium, refractive index is mu1, here is mu2. This value given by examiner. Obviously here mu1 is equal to 1. Okay? Remember that point. Now, R is equal to 20 centimeters and U is equal to minus 100 centimeters. Now, what is V? This is the question. Now, we got a picture about the question, and we are going to enter how to solve this numerical. Students, remember mu2 we know 1.5, mu1 is equal to 1, r is equal to 20 centimeters, u is equal to minus 100 because left side according to sign convention we have to take minus, v is equal to how much? This is the question. Now go for the solution. Solution. What is the formula? Minus mu1 by u plus mu2 by v is equal to mu2 minus mu1 by r is the formula. Okay, that means now substitute these values in this formula. Minus 1 by y1, mu1 is equal to 1, remember that point. What is u? U is equal to minus 100, minus 100 plus what is mu2? 1.5 whole by what is v? That only we have to find. So v only, that is equal to what is mu2? 1.5. 1.5 minus what is mu1? 1. 1 whole by what is r? Radius of curvature. How much? 20 centimeters. 20. Okay. Now that is equal to 1 by 100 plus 1.5 by v is equal to 0.5 by 20. Okay, please observe carefully. Dear students, minus minus going to be cancelled. So we wrote here 1 by 100 plus 1.5 by v is equal to 1.5 minus 1. How much? 0.5 by 20. That means 1 by 100 plus 1.5 by v is equal to multiply by 10 here, multiply by 10 here. Then what we will get? 5 by 200. Okay. Then how much? 1 by 40. Okay. So directly I wrote here. But how I wrote 1 by 40 in the place of 0.5 by 20? This is the reason. Multiply by 10 gives 5. Multiply by 10 in the numerator as well as denominator without changing the value of this term. Therefore, it becomes 200. Gives 1 by 40. Okay. Now I am erasing this one. Thank you. Therefore, what we will get? Three by 2v is equal to 1 by 40 minus 1 by 100. Okay, tell me what I did here. 1 by 100 I taken towards right side. Therefore 1 by 40 minus 1 by 100. Okay, here 1.5 I wrote as 3 by 2. Okay, V as it is I wrote as a V. Once again I am repeating, this 100 I taken towards right side. Therefore 1 by 40 minus 1 by 100, and 1.5 I wrote as 3 by 2 because 3 by 2 gives 1.5. Therefore 3 by 2. V I wrote as a V. Okay, now tell me 3 by 2, 3 by 2V is equal to, what is the LCM for this one? 200. How much we get? 5 minus 2 times 2. That means 3 by 2V is equal to how much? 3 by 200. 3 going to be cancelled. That means 1 by 2V is equal to 1 by 100. Okay? That means 2V, 3 going to be cancelled. Therefore 1 by 2V is equal to 1 by 200. Therefore reverse it. 2V is equal to 200. Therefore V is equal to 100. Okay, that means here V is equal to plus 100 centimeters. That means the image is formed at a distance of how much? 100 centimeters from the glass surface. In the direction of incident light. Okay, incident light. So this is U, this is V. That is why it gives a positive, it is negative. Okay, so this is the approximate diagram for this one. Like this we have to solve such type of the numericals. Thank you very much.